Hi everyone, this is just an extra video on solving or simplifying expressions using exponent laws. So I got a lot of questions about these, so I thought I'd just make one more video to see if that helps. Okay, so here is an expression right here. And it's got some x's and they have exponents. So we're gonna simplify them using the laws that we learned. So first I'm gonna start with my numerator. And I know that the multiplication law is to add the exponents. So these two x's are being multiplied by each other, so I can add their exponents because they have the same base. They're both x's. So I'm gonna make it x to the power of 7 divided by x to the power of 2. Now I just have division left. So I've got two powers with the same base, so I can subtract their exponents, making this x to the power of 5 because 7 minus 2 is 5. And that is our final answer. Okay, let's try the next one. We have 3x squared divided by 6x. So nothing to do in the numerator, so I'm just going to divide them right away. Okay, so let's start with the 3 and the 6. The 3 and the 6 are just regular old numbers. We call them coefficients because they're in front of a variable. And I'm just going to simplify them like I would a normal fraction. So like 3 over 6, how would I simplify that? I would divide them both by 3, making it 1 over 2. So that's what I'm going to simplify 3 over 6 to be, 1 over 2. I'll just write the 1 for now. And then my x's. So I've got an x squared and an x. So the only way to simplify those two things is using my exponent laws for division. So this guy actually has a little exponent 1 on it that we don't write. So when I subtract my exponents, 2 take away 1 would be 1. So I'm just left with an x to the power of 1 in the numerator. So actually this could just be written as x over 2, or you could write it as a half x, same thing. Next question, this one's humongous. But turns out there's just some division laws stuff that we need to do. That y is like totally taking over the space of the, I'm just gonna make that a little smaller. Okay, so let's do this. So I'm gonna start with my numbers. So I got 4 and a 2. So I'm just gonna divide those like normal. So 4 divided by 2 would just be 2. And then I'm gonna deal with my exponent laws. So the x's, I have x cubed divided by x. So if I subtract my exponents, I'm left with x squared. And then the following two, I have y to the power of 4 divided by y to the power of 6. So when I subtract those, I would get 4 minus 6 is negative 2. But I don't want to write that like y to the negative 2 because I don't really like writing negative exponent stuff. So a better way to write that would be to keep the y in the denominator. So y to the power of 2. Which makes sense because there was like 6 y's down here and only 4 up here. So it makes sense that 2 would be left in the denominator after we simplify. And that would be the final answer. Next question, 5x squared divided by x to the power of 6. Okay, nothing to do with the 5, so I'll just leave it there. And then x squared divided by x to the power of 6, same thing as above. I'm going to leave it in the denominator because there's more of them there. And 2 minus 6 would be negative 4 or positive 4 if it's in the denominator. So we wouldn't want to write it like 5x to the negative 4. Well, you can. But it's just more acceptable to keep exponents written as positive exponents. So this is the answer we would prefer. 5 over x to the power of 4. And if there's a case where you actually don't have this coefficient, like maybe you just have a 1. So say you just had like x squared divided by x to the power of 6. When you're simplifying that and you get x to the power of negative 4, same thing. We like it better when exponents are positive. So if we leave the x to the power of 4 in the denominator, that's better. And there would just be a 1 on top. So if you think about it, there's always a 1 in front of a variable, a coefficient of 1. So this would be our final answer. All right, I hope that helps a bit.
Please come to the phys ed office to